Hello student, today we are going to discuss about Aitken's delta square methods. What is Aitken's delta square methods? In Aitken's delta square method, we accelerate the rate of convergence of a iterative method. Here we focused on a fixed point method, how we accelerate the rate of a convergence of a fixed point method using the Aitken's methods. So, what will happen in a Aitken's delta square methods? We improve the rate of a convergence, means accelerate the rate of a convergence, convergence of any iterative methods. Now here we focus on a what? Here we focused on a fixed point method. And what is the iterative scheme of a fixed point method? As we know that iterative scheme of a fixed point method is a x plus 1 equal phi xn. This one is the iterative scheme of a scheme of fixed point method. So this one is the iterative scheme of a fixed point method. Now what is the rate of a convergence of a fixed point method? Rate of a convergence means, how we define the rate of a convergence? Means a relation between error after nth iteration and n plus 1 iteration. So error after nth iteration and error after n plus 1th iteration, what is the relation? Relation is a what? En plus 1 equal C En. Here C is a what? Asymptotic error constant, error constant. And here what is the power of a k? K is a 1 here, the power is a 1. So here we talk about a fixed point method of order 1. Fixed point method of order 1, the rate of a convergence is a 1, means linearly it will converge to the root alpha. So rate of a convergence is a what? Rate of convergence is 1. Rate of convergence equal 1. So this one is a summary of a fixed point method. What is the iterative scheme? Xn plus 1 equal phi xn, this one is a phi xn. And what is the rate of a convergence of a first order iterative method is a 1, and here C be the asymptotic error constant. Now first we give the derivation of a Aitken's delta square method, then we solve one numerical problem, how we apply the Aitken's delta square method and try to compare with the result that we obtain when we apply the fixed point method, and what improvement will occur when we apply the Aitken's delta square methods. So first of all, we perform the derivation of Aitken's delta square method. So here what is the iterative scheme? Iterative scheme is a xn plus 1 equal phi xn. Xn plus 1 equal phi xn. If fx is a what? Let fx equal 0, V any algebraic and transcendental equation, written in the form of x equal phi x. And iterative scheme is a what? Xn plus 1 equal phi xn. This one is iterative scheme of a fixed point method. Suppose this one is equation number 1. So now if alpha with the root, root of fx, then what will happen? Then alpha equal phi alpha. Suppose this one is what? This one is equation number 2. Now we define the error after nth iteration, error after n plus 1th iteration. So if we define error after nth iteration, En equal xn minus alpha, xn with the approximate value after nth iteration, and alpha is a what? Alpha is a actual root. So a positive difference, here we denoted the positive difference by the En with the error after nth iteration. Now En plus 1 with the error after n plus 1th iteration. So En plus 1 equal xn plus 1 minus alpha, and similarly En plus 2 equal xn plus 2 minus alpha. Now what is the rate of a convergence of a fixed point method? As we know that now by rate of a convergence of fixed point method, rate of a convergence of fixed point method is a what? En plus 1 equal C En. En plus 1 equal C En. Now in a similar manner, what is the meaning of this one? Error in a next iteration equal to the C time of a error in a previous iteration. Means error in a n plus 1th iteration equal to the C time of a error in a nth iteration. Now in a similar manner, if we write En plus 2 equal C En plus 1. Now what is the value of a C here? The value of a C become what? Suppose this one is equation number what? This one is equation number 3. And this one is equation number 4. Now from 4, C equal En plus 2 divided by En plus 2 divided by En plus 1. Okay. So now putting the value of a C in equation 3. Putting the value of a C in equation 3. Then what will happen? En plus 1 equal C means En plus 2 divided by En plus 1 into En. After simplification of this one, this become what? En plus 1 whole square equal En into En plus 2. Now we put the value of En plus 1, error after n plus 1th iteration, error after nth iteration, error after n plus 2th iteration by these equations. Means error after nth iteration, error after n plus 1th iteration, error after n plus 2th iteration. Now if we put these values, then what will happen? We put these values here, xn plus 1 minus alpha whole square equal En plus 2 means xn minus alpha into xn plus 2 minus alpha. So, if we put these values, then this become what? Once we write the expression of a previous slide, means we write the expression of this one, then this become what? En plus 1 whole square equal En plus 2 means En into En plus 2. En plus 2. Now, putting the value of En plus 1, En plus 1 is what? Error after n plus 1th iteration. So, this become what? This become xn plus 1 minus alpha whole square, this one equal xn minus alpha into xn plus 2 minus alpha. If we simplify this one, then this become what? This become xn plus 1 whole square plus alpha square minus 2 xn plus 1 into alpha equal xn minus xn plus 2 minus alpha xn minus alpha xn plus 2 plus alpha square. Now, alpha square cancel out and equate the term associated with the alpha and all other term on a right hand side. Now, if we move these term on a left hand side, then this become what? This become alpha xn plus 2 minus alpha plus alpha xn here this one plus alpha xn minus 2 times alpha xn plus 1 equal what will happen here? xn plus 2 minus xn plus 1 square. Xn plus 1 square. So, if we consider here alpha outside, then this become what? This become xn plus 2 minus 2 xn plus 1 plus xn, this one equal xn plus 2 minus xn plus 1 square. So, what is the value of alpha? If we write the value of alpha here, if we write in the next slide, the value of alpha become what? The value of alpha become xn plus 2 xn plus 2 minus xn plus 1 whole square divided by xn plus 2 minus 2 xn plus 1 plus xn. Once we verify this one, xn plus 2 minus 2 xn plus 1 plus xn. So, after rearranging some terms, how we rearrange this term? Here we write xn plus 1 minus xn whole square. So, here if we rearrange this term after rearranging the terms, you may write here alpha equal xn time what? Xn plus 2 minus 2 xn plus 1 plus xn minus xn plus 1 minus xn whole square. If we rearrange the numerator, then this become what? xn plus 2 minus xn plus 1 whole square divided by numerator denominator this become xn plus 2 minus 2 xn plus 1 plus xn. So, if we simplify this one, then alpha become what? Alpha become here this one cancel out first term, then this become xn minus xn plus 1 minus xn whole square divided by xn plus 2 minus 2 xn plus 1 plus xn plus xn. So, this one is a what? This one is a iterative scheme. This one is a iterative scheme. Here there is an involvement of n, n plus 1 and n plus 2. So, here we write what? Here we write alpha equal what? Alpha equal xn plus 3. Here we write xn plus 3 means we write the approximate value of alpha equal what? Xn plus 3. Why we write xn plus 3? Because there is already there is a 3 term xn, xn plus 1 and xn plus 2. So, this one is also a limitation of Aitken's method. Aitken's method only applicable if we have 3 approximate values, 3 known values, and that 3 known values we obtain with the help of a fixed point method. So, what will happen here? Here we write xn plus 3 equal xn minus xn plus 1 minus xn whole square xn plus 2 minus 2 xn plus 1 plus xn. Now, the name of a method is Aitken's delta square method. Now, question is why this one is called delta square method? Why this one is called delta square method? Once we write the iterative scheme in the next phase, xn plus 3 equal xn minus what will happen here? Here xn plus 2 xn plus 1 minus xn whole square divided by xn plus 2 minus 2 xn plus 1 plus xn. So, here we denote this one using the forward interpolation symbol, means a forward difference operator. So, due to this reason this one is called delta square method, because delta is a representation of a forward difference. So, here delta is a what? Delta of a xn is a what? Delta of xn is a xn plus 1 minus xn, xn plus 1 minus xn. And what is the delta 2xn? Second order forward difference. Delta 2xn equal delta xn plus 1, delta xn plus 1 minus delta xn, delta xn plus 1 minus delta xn. Now, what is the delta xn plus 1? If we simplify this one, delta xn plus 1 become what? Xn plus 2 minus xn minus xn plus 2 minus xn plus 1, sorry, n plus 1 minus what is the delta xn? Delta xn become what? Xn plus 1 minus xn. So, if we simplify this one, then this become what? This become xn plus 2 minus this become minus 2 xn plus 1 plus xn, means this one is a what? This one is a second order forward difference of a xn, second order forward difference of a xn. So, you may replace this one, this one, here we write xn minus this one, you may replace by this one, means delta xn equal xn plus 1 minus xn. So, this become delta xn whole square divided by what is the value for this one? Value for this one with the help of this one. With the help of this equation, this become delta second order forward difference del to xn, del to xn. So, insert you may write xn plus 3 equal xn minus delta xn whole square divided by delta 2 xn, delta 2 xn. So, xn plus 3 equal xn minus delta xn whole square divided by delta 2 xn. Now, here why this one is called Aitken's delta square method? Because here there is a delta square second order forward difference. Here we use the concept of a second order forward difference, and the notation of a forward difference is a del. So, here we use the xn plus 3 equal xn minus del xn whole square del square xn. Due to this reason, this one is called Aitken's delta square method. So, Aitken's delta square method. As earlier we discussed, what is the limitation of Aitken's delta square method? Aitken's delta square method only applicable if we have a value of a what? Xn, xn plus 1, xn plus 2. Means for n equal to 0, means if we have a value of a x0, x1, x2, then we able to find out the value of a x3 with the help of a Aitken's delta square method. Because what is the iterative scheme? Iterative scheme is a xn plus 3 equal xn minus xn plus 1 minus xn whole square divided by xn plus 2 minus 2xn plus 1 plus xn, or you may also write this one xn minus del xn whole square divided by delta 2 xn. So, this one is a means n equal to 0. N equal to 0, what is the value? X3 become what? X3 become x0 minus x1 minus x0 whole square divided by x2 minus 2x1 minus x0. So, to find out the value of a x3, there is a need of a value of a x0, x1 and x2. So, x0 and x1, when we apply the Aitken's delta square method, first of all we find the values of a x0, x1 and x2 with the help of a fixed point method. Then we apply the Aitken's delta square method to find out the next onward iterative values, iterative approximate values, means to find out the values of x3, to find out the values of x4, x5, x6, x7 and so on.